Let's take a look at the physical and chemical changes and how they compare to each other. Now, physical changes are going to end up having just the physical properties change. So if I take an ice cube and I melt it, the temperature of it is changed. However, the polarity of that molecule does not change. That's the sort of thing we're talking about when we talk about physical properties and chemical properties. Now, no new substances will have been created either, since no bonds are being made or broken. So looking at a couple of examples of that, down here we have dust off. And that's going to be something that's difluoroethane, so 2 fluorines on an ethane. And when it's compressed as a liquid, and then we release it, it changes into a gas. The temperature of that will also change. However, no bonds are being broken, no bonds are being made. So it'll purely be a physical change. Another example of that would be an ice cube as it's melting. Now, if you're paying very careful attention, you'll notice there's a fly frozen in this ice cube. Was there a fly? I don't know why there is a fly, but there is a fly. Another example would be if we put sugar into water, sweetening up our lemonade or whatever, and it dissolves. The dissolved sugar molecules have not had any bonds break. We've made no new bonds either. All that we had was sugar molecules that were in contact, popped loose and overcame their stickiness forces, their intermolecular forces, stuck to the water molecules, and the water molecules kept them suspended. The water molecules are intact, the sugar molecules are intact. No bonds are made or broken, only a physical change. Now, if we have a chemical change and we are making and breaking bonds, and there's going to be a new substance being produced. An example of that would be taking another similar compressed gas, propane, very similar to this compressed difluoroethane that we had over here. When we release it, yes, there's the physical change going from liquid to gas phase, but I also sparked it and lit this blowtorch. And when I did that, you can see that the propane molecules are going to combine with some oxygen molecules. Bonds are going to break and then reform to make different combinations, giving you carbon dioxide and water. This would be an example of a chemical change. Now, also, if you want to tie it back to what we've described as chemical changes and the macroscale properties, you can see that we're generating heat when we burn this, and we're giving off light. I wouldn't go as far as to say there's a change in state of matter because the propane was already gas phase as it came out of the nozzle. So we definitely have a couple of our identifiers for macroscale observables for chemical changes, but still we will have to dial down to the microscale to identify for sure that it's a chemical change.